Hello, Trino Fest. Today I'm going to be talking about enabling performant data access use cases with AWS Athena. Before I go into the technical content of the presentation, I'd like to introduce my company and myself. I work for a company called Arctic Wolf, which is a cybersecurity company that helps organizations combat modern cyber threats via cloud-native security operations platform. As for me, I'm a senior software developer at the company, and specifically, I work in the distributed search and archival team. In terms of the agenda of the presentation, there are 7 sections. The first section, which will introduce the presentation, is a discussion on the data store that my team owns. I'll specifically be talking about some characteristics of that data store. Where do we source the data from? How is it stored? What kind of size is it? Once I talk about those characteristics, I'll move on to section 2, where I'll talk about some data access use cases that internal and external clients have, that they use through our data store in order to derive value from that. Once I do that, I'll move on to section 3, which is a quick discussion on the legacy service offering that my team has previously developed and maintained. I'll be specifically talking about the challenges involved with this legacy service. Once those challenges have been listed, that'll be a good point to move on to section 4, where I'll talk about the requirements for our next iteration service that basically are there to kind of address the challenges from the legacy service offering. In section 5, I'll introduce Athena's really attractive value proposition for us, but I'll touch on some potential drawbacks that we found when trying to apply Athena for our particular use case. And that I'll then introduce our solution that basically uses Athena, but puts in place other parts to overcome those drawbacks that I'm going to be talking about. In section 6, I'll be talking about the performance of this new service vis-a-vis the legacy service offering, and then I'll end the presentation with some next steps on how or what my team wants to kind of build upon what we've already achieved with Athena. So the data store that my team owns consists of enriched cloud and on-premises data. It's stored per customer, and it's sourced from a large pipeline that the company maintained by basically all of the teams in the company. The data isn't stored in a raw format. It's enriched with security-relevant data. It's stored on S3, and it's multi-petabyte in size, basically. Data in the data store is compressed, partitioned, and aggregated. So what you would see as a final product is a series of tab-separated files that hover around 20 megabytes in size. In terms of how we deliver value through this data to internal and external clients, the use cases that leverage our data store can basically be thought of as falling under 3 main categories. Investigations, these are generally security related in nature. So for example, an internal team might want a subset of the data that is emanating from a particular type of source for a few customers over a certain period of time. They'll generally be monitoring or be analyzing this data for a particular pattern, for example, to detect potentially suspicious activity. And generally this output is in a format that's compatible with some sort of existing tooling that they'd like to leverage. The second category is for compliance reasons, pretty self-explanatory. The final category is for our customer self-serve platform. It's essentially a graphical user interface that we provide for our external clients in order to provide them with capability to query the data that we have stored and enriched for them, so they can potentially derive insights from that or leverage it for their own needs. Regardless of the particular use case, the process of preparing the data for a client follows an established pattern. You start, of course, with our data store. You perform an operation to filter and or transform the data. Finally, the results are outputted with some variability in the output format, so something like a CSV or JSON, etc., depending on what the client needs. So input, small batch ETL operation, output, and that's pretty much it. We do have an existing solution that the company has developed and maintained over a few years. It served the company well, but there are definitely challenges we've noticed while maintaining and supporting this tool, specifically 4 challenges. The first stems from a design decision taken at the beginning of developing the service to try to be generic enough to support as many use cases as possible, and to really allow a client to play with the data in our data store in whatever way they'd like to do so. And in some ways, this flexibility has kind of paid off because our tool internally and externally is quite popular. But the issue with that is that once you allow a lot of flexibility in how you allow a client to access the data, you never know what kind of use cases develop, and sometimes those use cases are such that the data has not been optimized for them, and so that's less than ideal. Our second challenge is a kind of nice problem to have, basically. When the tool was developed, it was designed to meet the demand that we had a few years ago, but since then that demand has increased enormously, and the service is struggling to handle that growing service demand. The third is that our tool uses a proprietary query language, and that has caused a lot of issues for us, especially in terms of operational load, because the onus is on us in terms of providing documentation and training in order for users, existing and potential, to actually understand how to use the service well. Finally, the design of the tool is quite complicated. It consists of many moving parts, and that also creates maintenance and operational load. It also makes it difficult to quantify exactly the price of each query and each use case that is being used to access our data store, because there are so many different parts. It's certainly possible, we do it, but it makes it more difficult when you have to calculate the price of so many different subcomponents of the service. So based on these challenges, the team that I work for basically set out 4 main objectives that we want for the next iteration of the service. We want defined access patterns. We want the flexibility, of course, to be able to support plenty of use cases, but we want users to access our data in predictable ways, and we want to design our service around optimizing for those particular access patterns. Second, we want something that is performant at the scale that we operate in currently. Third, we want something that's user-friendly, so there's less toil on us towards training and providing more documentation than necessary. Finally, we want more deterministic pricing, so we want to be able to very simply quantify what is the cost of fulfilling the use cases that our data store supports. Based on these requirements, Athena's value proposition is very compelling. It has a powerful query engine, aka Trino. It's purpose-built for large data sets. It has an SQL syntax, which makes it very user-friendly. And finally, it has a clear pricing structure. To be specific, we're using the traditional pricing model for the service, which is $5 per 1 terabyte of data scanned. However, even though Athena is awesome and it provides a lot of value, there are some drawbacks, at least for our particular need. The first is, since we're using the traditional pricing structure, we are subject to the quota limits imposed by the service, which are basically limits on, among other things, the number of concurrent queries that you can run in one service account. And since it's a service account, it means it's a limit that not only does our team have to respect, but everybody else that's using Athena within the same service account. So that's one issue. The second issue is more as a result of the characteristics of the data store that my team owns. Since our file sizes generally are around 20 megabytes in size, that's quite a long way from the best practices recommended for Athena and for Trino, which is, as I understand it, maybe in the low hundreds of megabytes. Finally, Athena is amazing in the sense that it provides you the ability to really quickly query data in powerful ways, but we don't necessarily want to provide that capability directly to internal and external clients, because we want them to access our data in really defined access patterns. And so that's one particular drawback That's another particular drawback that we had with the service. But none of those drawbacks are deal breakers, and that is basically why my team chose to use Athena and why we chose to architect a solution around it. But before I go into the details of that solution through a system diagram, I'd like to introduce the concept of a log query. So a log query is a model that corresponds one-to-one with a particular use case that an internal and external client might have when accessing our data source. And so the idea is that when a client wants to access the data in our data source, they would run one particular type of log query workflow that will correspond directly to their use case. And a log query workflow is essentially a series of Athena queries that are run in order to service a small batch ETL operation. In our case, what we do is essentially run two create external table queries, one to represent the input data, one to represent the output data. After those queries are run, we run multiple insert into queries that are responsible for taking the input data, performing any filters and transformations, and then taking that data and putting it in the output table. I'll talk about how we deal with, or how we determine how many insert into queries to run in a following slide. But essentially, that log query abstraction basically addresses the first drawback, or one of the drawbacks for leveraging Athena, which is this idea of defining the access patterns that users have when accessing our data source instead of just allowing unfettered access. In the following slide, I'll talk about the system diagram that runs this type of log query workflow, and then I'll talk about how we address the two other drawbacks. So now that we've talked about this concept, the model of a log query workflow, which is an abstraction over a series of Athena queries to service a small batch ETL operation, let's talk about the service that we built to process these log query requests. The service is interacted with in two ways, either through a CLI or a GUI. Requests are made from these two sources into an API service, which is just an HTTP REST API backend. The API service is responsible for storing metadata. We use DynamoDB for that, and is responsible or contains the logic that populates or defines that log query workflow. So it creates the Athena queries necessary in order to service this request. Once that's done, the log query request is packaged put onto an SQS queue, and is then read by a service that we've developed that is called a query scheduler. And the query scheduler is a service that addresses the other drawback that we thought of when using Athena, which is this idea of having to request the quota limits. So the query scheduler makes sure that whatever queries are run, whatever Athena queries are run, they are only processed so long as they respect the quota limits. And so that is the other drawback addressed for leveraging Athena. In the Athena portion of the graph, you'll notice that there are multiple icons that represent the AWS Athena service. And essentially in this section is where we address the final drawback of leveraging Athena for our particular use case. So if you'll remember, I talked about how the way that the file sizes are in our data store is not really optimal. They're about 20 megabytes in size when they probably would create much better performance if they are hundreds of megabytes in size. And so we needed a way to architect around the degradation in performance temporarily until we can begin aggregating our file sizes to be larger. The way that we do that is that we construct our Athena queries such that they run on the unique partitions. Each one is responsible for a particular partition value based on the partition, or based on the way that we partition our input data. And that basically addresses the final drawback of leveraging Athena. And that's why we created the service, and that's why Athena works for us. And this is just kind of summarizing what I've talked about in terms of access control. We've created this log query abstraction that defines particular use cases and doesn't just allow ad hoc access to our data store. We've addressed the quota limits through our query scheduler service. We've addressed temporarily the suboptimal file sizes by parallelizing the Athena queries. And specifically, we use S3 inventory. We have logic tuned around that in order to make our queries efficient. And in terms of performance, we've run the same types of use cases with this new service versus our legacy service, and our performance runtimes have dropped dramatically. Things that used to take hours using our proprietary solution now basically run in under a minute, and that's without major improvements that we still can achieve, which is to create larger aggregated file sizes and to transition to column-oriented storage, like Iceberg, for example. And that brings us to where we're headed, the final section of this presentation. So my team would like to explore what kind of performance improvements we can get by increasing the file sizes for the files in our data store. We want to then take a look at changing the way that we store the data in order to use a column-oriented storage like Iceberg. Once we're ready to do that, we feel that we can expand our use cases to do even more with Athena. And then who knows, maybe as a final step, we'll test drive a self-managed Trino deployment for a greater control over how we structure our queries, how we can kind of fine-tune the parameters of our query execution. With that, that's the end of the presentation. Thank you so much for listening. Take care.